So alright, this is our timeline video of the blind inference project. So in the wave one, what we did this confidential inference. We created we trained basically our machine learning model on a confidential medical dataset and hosted its weights after decrypting it on-chain. And then using coefficient processors, we were able to do this big computation on-chain and able to decrypt the results to the whatever the user wanted, whoever the user uploaded their attribute data points, and then he uploaded on chain. The computation happened, it receives back and decrypted the final output there. Okay, so all of this was possible using the Fhenix co-feature processors. But what we found there was the shortcomings were that these models are really simple, and if we're going to run these on chain, that will be impossible in these terms right now, and as well as that the limitation of the TFHE being not linear in its nature. So those were the problems. Because of this, we shifted in the second wave to a more quorum base. That is, we're going to run all these computation off chain, but we're going to give the accountability that these are verified by different users or different verifiers, whatever the main node executed. And so you can have accountability that, okay, whatever I'm getting my output is actually run by somewhere that is verified with the cryptographic proofs, as well as the whatever these computations actually are happening in this trusted execution environments. So the prompts are actually encrypted end to end. So we did this in the wave 2 using our numerical outputs. Okay, so you upload your confidential numerical inputs, and those get encrypted and stored on chain. Again, the leader and the verifiers decrypt those attributes on their side in the trusted execution environment, and then they run the computation. Again, the consensus come that okay, they match these values, and you get back and decrypt it and get the whole cycle done. So in the third wave, we extended this idea to have in the textual inference. So what do I mean that you now going to have this. Now you can actually do the same thing with the text now. So what can happen is your text get encrypted using the AES GCM 256 algorithm, and this encryption key will be again more encrypted using the coefficient and will be stored on chain. Now these are the encryption key that we're going to be using to decrypt your blob that we created using the algorithm, and this blob actually get uploaded to the IPFS, and this IPFS, we upload this blob to the IPFS, we upload this encrypted keys to on-chain. This blob will be received by all the leaders and verifiers, and this encrypted key will be only given permits to these three that is the one leader and two verifiers, and they can only do this. And then again decrypted and submits back to the quorum. It reaches the consensus that again all the leaders and the verifiers actually coming to the consensus that they are being verified, and the ICL actually the quorum sends back to you, and you get the executed correct output. And in the fourth wave, we introduce our node package that if you want to join us as an infrastructure layer, how we can do it, and we'll be having video about it as a demonstration will be in the next another one. And in the fifth one, we basically sums up all of this and gives you a complete testnet live example that you can run on your browsers, and a complete end-to-end flow of what you actually have right. And for the futures one, we going to have a better consensus one. So for the future cases, we're going to be introduce more nodes. We're going to introduce more open source models, as well as a better way to have these consensus reached. Right, we are now doing everything cryptographic proof wise. So we want to have more having some machine learning models, maybe the agentic inferences, so that we can actually verify these outputs without running the actual inferences multiple times. That actually costs a lot of computation. And as well as we going to be having more of a decentralized inference coordination layer. Right now it's a centralized one, so it's pretty much non-prone to attack, but if in the future we'll be having decentralized one, so one side even goes down, maybe attacked, so the whole pipeline, the whole infrastructure is still alive, right? So that's pretty much our future scopes. And yeah, thank you you can proceed with the videos. Thank you.